Today we're going to be looking at dividing monomials. When dividing monomials, you are going to subtract their exponents. That is one way you can look at it. Like if you look at number 1 and I have b to the 5th over b to the 2nd, I can say that that is b to the 5 minus 2, which is b to the 3rd. Another way you can look at it is figuring out where there are more. There are more b's on top, so that's where I'm going to have my variable on top. And how many more are up there? There are 3 more up there. It kind of goes back to what we did on the hook, where you're looking at having 5 b's on top, 2 b's on the bottom, 2 would cancel, and what would be left is 3 on the top. In example number 2, make sure you put that exponent in, and then I look at the m's. Where are there more m's? There's more m's on top. How many more? There's 6 more. N's. More n's on top. How many more? There's 3 more. And then you could always say that on the bottom there is a 1, or not, that we don't have any variables left, so that means there's a 1. But if we don't have anything left on the bottom, we can just write what's on the top. Looking at number 3, there's more x's on top, so x to the 1st, and more y's on top, and how many more? 1 more. You could also write that as xy. A couple more examples. With numbers, we're still treating them like we always did. We'll just do that division. That's what that is. 81 divided by 9 is 9. There's more a's on top. How many more? 3. There's more b's on top. How many more? 2. Because there's 3 on top, 1 on the bottom. So one of them is going to cancel from top to bottom. 64 divided by 16 is 4. Looking at my g's, there's more on top. There's 2 on top. And how many more are up there? There's 1 more. Looking at my h's, there are more on top. How many more are up there? There's 2 more. Or 7 minus 5 is 2. For number 6, 3 divided by 3 is 1. There's 3 m's on top, 3 m's on the bottom, so they would all cancel out, so I don't have any more m's. Or 3 minus 3 is 0. Looking at the n's, there's more n's on top. How many more are up there? There's 1 more. This can also be written as just n. Something to remember is that anything raised to the 0 power, except for 0, is equal to 1. So, 528 to the 0 power is the number 1. Just like if I have x to the 0 power, that's the number 1. It's not x to the 1st, it's the actual number 1. We're also going to be looking today at negative exponents. So if I have a negative exponent, I need to make it positive because I don't want to have negative exponents. They're not allowed. It's like keeping a fraction unsimplified. So this is a number over 1. To get rid of that exponent being negative, I can move it down to the bottom. So 1 on top, and what's on the bottom? A to the positive n. So that's what I'm doing. I'm just totally flipping it. I don't know why that equal sign is there. If it's already on the bottom, I can flip it up to the top to make it positive. So a to the n over 1, which would just be a to the n. So wherever there's a negative, I move it either top or bottom so that it becomes a positive exponent, not numbers. That's not true with numbers. So looking at this first example, I see this negative. This is actually a number over 1. So I need to take the negative exponent and move it to the bottom. So my top is going to be y to the 0. On the bottom is x to the positive 4. Now we just talked about anything to the 0 power is 1. So if I'm going to simplify this, which I need to do, it's 1 over x to the 4th. All right, looking at number 8, we're going to look at this 2 ways. First, I'm going to do my division. 3 over 18 reduces to 1 over 6. There's more R's on top. How many more? 1. There's more S's on top. How many more? Or more S's on the bottom. Sorry. More S's on the bottom. How many more? 2. So that would be our answer, or we could write it R over 6S squared. If you look at it as subtracting the exponents, I'm going to do it both ways. You still get 1 over 6. You subtract the exponents, you get R to the first. You subtract the exponents on the S, you get S to the negative 2. But then because that's negative, it needs to move to the bottom. So you can do it either way. You can either subtract exponents and look at where there are more, top or bottom. All right, looking at number 9, first thing I see is that negative exponent. I'm going to move that to the bottom. That doesn't mean there's nothing on the top. There's something there. There's always a 1 out in front here. So there's a 1. Now I'm moving that x to the negative 3 down so it becomes positive. And I have x to the 4th on the bottom already. But I have to clean that up. There's no reason to have 2 x's in a problem. So how many x's do I have altogether? I have 3 and 4. So that is 7. And that goes back to what we did 2 classes ago, where you're multiplying bases with same base with exponents. You add those exponents, and that's what I did here. 3 plus 4 equals 7. All right, looking at number 10, I've got a lot of negative stuff to move. We'll move that first. R to the 5th is now on the bottom. Move that. S to the 2nd. That R to the 3rd can stay. That's why I left that little space there, because I had already noticed that that one was going to stay. And this guy's going to go on top. S to the 3rd. Now I can look at my variables that are the same. My S's. I have 3 on top, 2 on the bottom. There's 1 more on top. So that's going to be S to the 1st on top. Now looking at my R's, I have 2 of them on the bottom here. So I'm going to put those together. R to the 5th and R to the 3rd is R to the 8th. And this could be written as just S over R to the 8th. Now number 11, we're going to bring in some stuff from 2 classes ago. We have this top. This top monomial is in parentheses and it says to write it twice. So that's what we're going to do. X to negative 3, y squared. X to negative 3, y squared. And our denominator says to take what's in the parentheses and write it 3 times. 4x squared, 4x squared, 4x squared. Then I've got some negatives that need to move. We'll move those down to the bottom. So what's on top? Y squared, y squared. What's on the bottom? 4x squared, 4x squared, 4x squared, and then x to the 3rd, because I'm moving it down, and another x to the 3rd. Cleaning that up, y squared times y squared is y to the 4th. Same base, I add my exponents. Numbers, 4 times 4 times 4 is going to be 64. And then I have x squared, x squared, x squared, x to the 3rd, x to the 3rd. So I have to add all those up. 2 plus 2 is 4, plus 2 is 6, with another 6. So that's x to the 12. All right, the next one. Our numerator occurs twice. 3x squared, y to the negative 1, times negative 3x squared, y to the negative 1. My numerator, 3 times. 2x to the 1st, y to the 3rd. 2x to the 1st, y to the 3rd. 2x to the 1st, y to the 3rd. Cleaning up that top. Negative 3 times a negative 3 is 9. X to the 2nd, x to the 2nd is x to the 4th. These guys got to move down, so I'm not going to worry about them right now. The top, or the bottom, their denominator, 2 times 2 times 2 is 8. X to the 1st, x to the 1st, x to the 1st is x to the 3rd, because I have 3 of them. Y to the 3rd, y to the 3rd, y to the 3rd, is going to be y to the 3 plus 3 is 6, plus 3 is 9. I'm also moving these two y's down. Those ones I circled. Now I need to put all those together. So 9x to the 4th over 8x to the 3rd, y to the 9, 10, 11. Oops, but now I have an x on top and an x on bottom, so I need to clean that up. And more x's on top. So that's where my x will stay. So on top I have 9x, because there's 1 up there. On my bottom I have 8, 1 to the 11. And that's my final answer. Everything's cleaned up. I can't simplify those numbers. All right, let's go to the back. All right. Looking at the back. One more problem here. So looking at that problem, we can see that everything is in the parentheses and has a negative exponent. So that means I need to make that exponent positive by flipping everything. So I'm going to put negative, negative 7x y to the 3rd on the top, and on the bottom is 14x to the 3rd, and now it's a positive exponent. So now I can take everything in those exponents twice. Negative 7x, or in those parentheses. Twice. Negative 7x to the 1st, y to the 3rd, over 14x to the 3rd. Negative 7x to the 1st, y to the 3rd, over 14x to the 3rd. Now I can do a little cleanup. Negative 7 times a negative 7 is positive 49. X to the 1st, x to the 1st is x to the 2nd. Y to the 3rd, y to the 3rd is y to the 6th. My denominator, 14 times 14. That may not be one you know off the top of your head. And remember, you should always double check with your calculator anyway. That's 196. And then x to the 6th. Now we got to do a little bit of cleanup. 49 and 196. We have to see if there's something that will go into both of those. And we should see that, you might not see, but if not, you just try different things. You know that 7 could go into both of them. You know that 14 might go into both of them, but actually 49 goes into both, so it's 1 over 4. More x's on the bottom, and how many more? 4. More y's on the top, well, all the y's on the top. 6. We're also going to look at dividing numbers in scientific notation. There's 2 ways we'll look at this. One is by doing them by hand. Okay, so looking at doing it by hand, we need to divide this slide should be there. Divide the decimal portion of the numbers, so you divide that first. Then you divide the powers of 10, and then you would write correctly in scientific notation. So if I'm looking at this 14 and I'm doing it by hand, I would do 1.4 divided by 5.6, and that gives me 0.25, times 10, well, I'm looking at my powers, 3 minus 8 would be a negative 5. Now, though, I would have to move this decimal and think about how that affects that sign. Probably the best thing to do would be to rewrite that number without the scientific notation, knowing that if it's negative, it's 1, 2, 3, 4, 5. And then taking a look at that number and saying, oh, I've got to move the decimal over here. So how many places would that be? 1, 2, 3, 4, 5, 6. So the actual number would be 2.5 times 10. Now that's one way you can do it. Or you can use your calculator and follow these directions, which says type in the decimal portion. So 1.4. Then press second comma. Second comma, above that you'll see there's EE. Then put your power of 10. You don't put the 10 in there, just the power of 3. Then we would use our division bar, divided by 5.6, our decimal portion. Second comma, and put our power, which is 8, and then hit enter. And we would get our 2.5 times 10 to the negative 6. So same thing with number 15. You could divide this, say that that would be 2 times 10 to the 4 minus a negative 3 would be 7. Or use the calculator. This one we don't need to change because it's actually in scientific notation. You could use the calculator, say 3.4, second comma, to the 4th power, divided by 1.7, second comma, to the negative 3, and enter, and you get the same answer. It's not in scientific notation, so you have to change it. All right, you have a couple problems to try on your own.